This is 17.6 and it's about equations with radicals. So solving equations involving the square root or squared. So the first example I'm going to give you is the square root of x equals 6. So if you're going to solve this problem, because what you want to do, the steps that you want to do first, is you want to make sure that the square root, that the radical, is isolated. So what I mean by isolated is there's two sides to an equation. If I draw a squiggly down the right and left side, that splits it into two. And you can see that the radical, and the radical is this thing right here, is isolated. It's on that side by itself. I'll show you some that aren't. So once you've isolated the radical, how you get rid of the radical sign, the opposite of square root is squared. So you have to square both sides. The reason why you do it to both sides is because you have an equation, and whatever you do to one side, you have to do the other, because an equation, again, is like a teeter-totter, and you don't want it uneven. It's an equals in between. You want to keep it equals. So the square root and squared, these two things right here, will cancel themselves out, and you will get x. And on the other side, 6 squared is really 6 times 6, so you'll get 36. So then your answer is x equals 36. You can check it, because you can put the 36 in where the x is in the original equation, and try this on your calculator and see if it does really equal 6. If you don't know how to use the square or the radical on your calculator, just send me a text or give me a call and I'll walk you through it. You really do want a calculator that you can do that for this section, or for this class. So you can try this one on your own, so you can pause the program if you want and try it, and then come back and see if your answer is correct. And I'll work it out right now. So I'm going to make sure that the radical is isolated, and this time I put the radical on the right just to show you that it can be right or left. It doesn't matter, it's just two sides of an equation. I'm going to square both sides so that I can get x by itself. And again, because the square root and squared, or the radical and the squared sign and the exponent, cancel each other out, I get 81 on the other side. So x is 81. If I want to make sure, I can rewrite the original problem but put an 81 in there where the x is, and try this on my calculator and see if the square root of 81 really is 9. So cubed, or the cubic root, should be the same thing. So if I have the cubic root of x equaling 2, I should be able to do the same thing, isolate the radical, so the radical is already isolated, but this time I don't want to square it, I want to cube it, because I need the cubic root and the cube to cancel itself out. So I cube it, whoops, and I cube the other side, and I get x on the left, and on the right, remember that's not 2 times 3, so don't think it's 6. If you're not sure, make sure you put it into your calculator. And so it's 2 times 2 is 4, 4 times 2 is 8. And again, if you don't know how to do this in your calculator, give me a call, because it's going to help you so much on that final. You don't have a lot of time and you don't want to be doing everything by hand. What if you make a mistake? So, and then you can double check or check yourself again. This function on the calculator is a little bit more tricky, but you should be able to, take the cube root of 8 and see if it does really equal to check it. The next problem is a little more complicated in that inside the radical there's an operation, 2x minus 1. And so the steps still follow the same. You want to make sure that you isolate the radical, and right now the radical is isolated, and so you can pause this and try it on your own if you want, but it follows the same idea. Square both sides, because squared and square root are opposites. When I do that, my radical and my squared cancel, and I get 2x minus 1 on the left, and on the right I get 9 because it's 3 times 3. Now I still have to solve the equation, so that's why it's a little more difficult in that you have to just use your algebra skills, your inverse operations. So you want to add 1 to each side. You get 2x equals 10, and you want to divide by 2 on each side. So x equals 5. You can double check it again. You don't have to, but you can. The original problem was 2x minus 1 inside the radical. So I'm going to rewrite the problem with a 5 in there. And 2x doesn't mean 25, it means 2 times 5. So if you're going to do this in your calculator, make sure that you put parentheses around here to show the calculator that you want that whole thing in the radical. But you can do it by hand too. So 2 times 5 is 10. And 10 minus 1 is 9, so you get the square root of 9, and the square root of 9 is 3. So it does check out. So you can try this one on your own. So here's one that's similar. So you can pause this and try it on your own. And I'll work it out kind of quickly here for you. So I'm going to square both sides. I'm going to get 4 minus x on the left and 9 on the right. I'm going to take 4 away. This is where sometimes students will mess up because this minus goes with this x, and this is a positive 4. And so a lot of people will look at this subtraction sign right here in front of the x and say, oh, I got to add 4, but that's not true. And so I'm going to subtract 4 from each side. That leaves me with a negative x equals 5. Oops. There we go. And then I can divide by negative 1 so that I get x equals negative 5. Okay, and here's one where the radical is not isolated. So I've kept saying, you know, isolate the radical, isolate the radical. Here's one where it's not. 4 minus x plus 5 equals 8. And so remember the steps that I wrote before. So there's the steps again. So I'm going to isolate the radical first. So I have to subtract 5 from both sides. The reason I have to do this, it's going to get really ugly. If I square everything, it's not going to be like squaring the radical and then squaring the 5 and squaring the 8. It's actually going to force me to use FOIL on this radical and the plus 5, which is going to get, it's going to force me to multiply a binomial times a binomial, and it's going to get pretty ugly. And so the way around that is to go ahead and isolate it so that when you do use the square, that you end up canceling that whole left side. So 8 minus 5 is 3. Wow. 3. And then I'm going to square both sides. And I'm going to get 4 minus x equals 9. I'm going to subtract 4 from each side. I get negative x equals 5. This is similar to that other one. And x equals negative 5. So let me write one and then you can try it on this next screen. So there's the problem. You might want to hit pause. The book only has a couple of these, but I did notice that on the review that the math department makes for you to study for the final, there's quite a few of these on there, so I want to make sure you know how to isolate the radical. Also, I put some on the quiz. So go ahead and pause it and try it on your own, and then come back and see if you did okay. So I'm going to isolate the radical. And make sure that you don't skip steps. They will dock you points for that. A lot of points on the final. So I'm going to square both sides so that I get 2x plus 5 on the left, and I get 9 on the right. I'm going to go ahead and use my inverse operations, my algebra skills, and solve for x. And I get x equals 2. I can plug that back in. Always, if you have extra time on a final, you probably don't want to do it for every single problem. There's certain problems that you have to do it for, and we'll talk about those later in the course. But since it is 50 minutes, you probably don't want to do it on every problem. But let's say you had extra time at the end, then you probably want to go ahead and check your answer. All I'm doing is solving inside the radical. And the square root of 9 is 3. So I do get 5 equals 5. And so it checks out. So the next kind of problem is when there's a radical on both sides. So if I have 5x minus 1 equals x plus 1. Since there's radicals on both sides, I can go ahead and square both sides. And that works pretty nicely in that you get 5x minus 1 on one side and x plus 1 on the other. Now I can use my algebra skills. I can pull all my x's over to one side. And this is just the stuff you learned a couple of classes back. And you get x equals 2/4, which is x equals 1/2. Okay, so here's one for you to try. Here's one that you can try. Okay, so you might want to pause it and then come back, see if you did it right. Okay, I'm just solving for a. It's a minus. Taking care of all my add and subtract first. And now my multiply or divide. And I get a equals 10. So I should be able to put a in, or 10 in where a is, solve both sides, and I should get the same answer on both sides. And here's some problems that don't have the radical in it, but involve the radical to solve it. If I have x squared equals 16, and I want to solve for x, I know that squared and square root, the radical, are opposites, so I can use the radical on both sides. Now I know these two will cancel, but remember that this is x squared, so that means x could be a positive or a negative. And so when these cancel and I get x equals 4, I know that it can be positive 4 or negative 4. What that means is x can be 4 and x can be negative 4. So there's two answers to it. The reason there's two answers is because think about plugging it back in. Oops. If I write this the way it was written originally, x squared equals 16, and I think about plugging these in where the x is, well, I know 4 squared equals 16, but I also know that negative 4 squared equals positive 16, because negative 4 times another negative 4 equals 16, and so does positive 4 times a positive 4. And so it has two answers, and you would have to write both of them to get full credit. So here's one that you can try. So try that one. You can pause it. Okay, so I'm going to take the square root of both sides, and I'm going to get x equals positive and negative 6. You do have to show the work by showing the square root. to get credit on the final. Like I said, they're brutal on the final if you don't show credit. Okay, two more things to cover in here. One is a story problem. You will come across a few story problems on the final. So you want to make sure that you pay attention to those since there aren't very many. And really that's where the math is applicable. This story problem I'm going to copy right out of the book. You can look at it. It's on page 261. And it's an equation that they give you, and they say this is the equation for finding the weight of a bird. Okay, so here's the equation that they give you. They say if you want to find the weight of a bird, you have to know their wingspan. So the A of W, that's a function saying that you can find the weight, or the weight of the bird if you know the wingspan. Okay, so the W here is where you would put the weight, and right here would be where you put the wingspan. So then they will tell you, let's see if I find the question. They will ask you a question like, they'll give you this. They'll say the bird has a wingspan of 600, and they'll say find the weight of the bird who has a wingspan of 600 square inches. And so then you have to solve this. So again, we're going to isolate the isolate the radical. So I'm going to divide by 100 so that the radical is by itself. And I'm going to get 6 equals the cube root of W squared. So now I'm going to cube both sides to get rid of the radical. So I get 6 times 6, which is 36, times another 6, which is 216, equals W squared. So now how do I get rid of the squared? I use the square root. So let me change colors. I use the radical. So what times what makes 216? So I get W equals, and it comes out to about, that's the about symbol, 14.7. So the weight of the bird is about 14.7. What are those, pounds? Okay, and it's okay to use your calculator to do that. Take the square root of 216. Then the last thing in this section is the Pythagorean theorem, and you have most likely had that before, but let me run you through it just in case. Probably spelling it wrong. I'm a horrible speller. But the Pythagorean theorem is a theorem that a Greek philosopher came up with. His name was Pythagoras, and he studied right triangles, so only triangles with right angles. And he discovered that if you take the two shorter legs, and we're just going to call the shorter legs A and B, doesn't matter which one you call A and B, or B, and he takes the long leg and he calls it C. That's important. He discovered that if you have if you square what A is, and if you square what B is, it should equal C squared. There's kind of a cool video out there. I think you can just look on YouTube, and there were actually a few of them, but one of them was a water wheel, and it showed that if you had this right triangle, and they made a, let me see if I can do this. They made a square off of this side and a square off of this side, and then there was a tank right here. These two were filled with water, and as they turned the triangle, all the water went into here and it filled that, to show you that the square of the two short sides equals the long side squared. Okay, so if I had a problem like, if I said that A was 3 and B was 4, then I should be able to set it up A squared plus B squared, oops, pen's not picking up, equals C squared. So I should be able to say 3 squared plus 4 squared and find out what C squared is. well, 3 squared is 9 and 4 squared is 16. So that makes 25. So c squared equals 25. The biggest error is that students will say, oh, the third side is 25. They'll stop. But remember, it's c squared that's 25. So I need to find out what c squared is. So I take the square root of it, and I get c equals 5. Now, not all triangles are going to be 3, 4, 5s. It's not, doesn't mean the next one's going to be 5, 6, 7. 3, 4, 5 is a special triangle. The important part is that you pay attention to what C is. That C is always the longest side, and it's always the two short sides equals the long side. Okay? And this side is called the hypotenuse. You've probably heard of that before. The other sides don't have any special names. So one of the things you can do, let me see if I can find it. Excuse me. Let's see. If I have a triangle and I say this is 6 and this is 20, and I want you to find the third side, you need to remember that you have A, B, and C. And so A squared plus B squared is going to equal C squared. So A is 6, so 6 squared. They didn't tell me B this time, so I have to put B squared, and then I have a 20 squared. So notice that the unknown is not isolated. So 36 plus B squared equals 400. Take away 36. And B squared equals 364. And then take the square root of both sides, and I get B equals, and you could do it in your calculator. You could probably hear me doing it in my calculator. About 19.1. If your calculator says this, 2 squared 91, that's okay. This is left in radical form, and this is in decimal form, and we'll talk about those later. But either one on Pythagorean theorem is fine, unless the directions state differently. On Pythagorean theorem, they won't leave them that simple for you because they figure you've had it before. They'll give you something like a story problem where they'll say, you know, you have this tank, and the tank is 15 by 20, and they want to know what's the diagonal across the tank. And so then you're finding this. So you've got to realize that a tank's going to have a 90 degree. This is going to be your C. So then you're going to set it up. 20 squared plus 15 squared equals C squared. 400. What's that? I think it's like 600 and something. Oh, 200 something. 225 equals C squared. And that's 600 and something. 625. And I take the square root of both sides, and I get C equals 25. Then you can kind of check, because the diagonal should be the longest side. So that's more like what you'll see on the final. And that's the end of 7-6, I believe.